Hi everybody, we're now ready to do subtraction of polynomial expressions, seeing we understand that if we have a subtraction symbol, all the terms behind it will become the additive inverse. We will be adding the opposite. So in my first expression here, it's obvious I'm about to do subtraction. Well, to relate this to what we've already done, we know we cannot add if we have terms stuck in grouping symbols. Therefore, we cannot subtract if we have terms stuck in grouping symbols. So again, we have the grouping symbol parentheses, and we know to get rid of the parentheses, we do the operation of multiplication. We distribute by the number that's in front of our parentheses. Well, if we look at this set of parentheses, you'll tell me there is no number in front. You are correct. There is a number there. It's just understood, and it's not written. It's understood to be a 1. Now, from third grade math, if you multiply any number times 1, does it do anything? No. We learned in third grade 1 times 3 is 3. Multiplying by 1 does not change your result, your product. Therefore, I just want to make sure you understand. There are parentheses here. We cannot subtract yet because we have terms stuck in a grouping symbol. So to get rid of this grouping symbol, we have to multiply. Technically speaking, we're multiplying by 1. But we really don't need to distribute the 1 because we know 1 times any term will be itself. So 1 times 3a would just be 3a. 1 times 4y would just be 4y. So a lot of times what you'll see in algebra is if there's a coefficient of 1 in front of the parentheses, they just drop the parentheses because they understand multiplying by 1 doesn't change your value. However, when we come here, this is a subtraction symbol. We just learned the definition of subtract means to add the opposite. So technically in algebra, we are never subtracting. Every time we see the subtraction symbol, we will change it to addition and make any terms behind it the opposite, the additive inverse. So the opposite of 2y is negative 2y. The opposite of negative 3a is positive 3a. Now, a lot of you have been taught another way to approach that. This way is also correct. You can think of, in front of this set of parentheses, is the number negative 1. And if you think of there being a negative 1 in front, if I distribute a negative 1 to both these terms, well, we know multiplying by positive 1 wouldn't change your value. Multiplying by a negative 1 will change signs. So a negative times a positive makes a negative. A negative times a negative makes a positive. So, ladies and gentlemen, either approach is mathematically correct. You could think about this as being the operation of subtraction. Subtraction, the definition says to add the opposite. Or you can think of it as saying in front of my parentheses there is the coefficient negative 1. And if I distribute a negative 1, it changes the signs. Okay? Now, are we done with this expression? No. Now that we've gotten rid of the parentheses, we have 1, 2, 3, 4 monomials, and our job is now to collect like terms. Bring together who's alike by addition or subtraction. Remember, we know if we're going to add if the signs are the same. We know we're going to subtract if the signs are different. So first, let's find our like terms. 3a and 3a are alike. They both have the variable a. I have 3 apples and 3 apples. Both of those are positive, so we'll add and we'll get 6 apples. Our other like terms are the 4y and the negative 2y. Well, because the signs are different, we're not adding, we're subtracting. 4 take away 2 is 2. That would be 2y. This is our bigger number, so that's why our 2y would stay positive. We know we're going to stop right here because this says add, and these are not like terms. Therefore, we can't go any further. And that is our algebra expression. Okay, let's try one more. Here is our algebra expression they want us to simplify. Again, simplify says do the operations you see. So we see parentheses, and we know the only way to get rid of parentheses is to do the distributive property. So on our first one, we're going to distribute a negative 2. So negative 2 times 3x is negative 6x. Negative 2 times negative 5 makes a positive 10. Okay? We again have another set of parentheses. So to get rid of our parentheses, we're going to distribute, and this time we're going to distribute a positive 7. Positive 7 times negative x squared would be a negative 7x squared. Positive 7 times positive 4x would be positive 28x. Okay? We're moving along. Now I see subtraction. Now, you can think of this as, what is the definition of subtraction? Subtraction means to add the opposite. The additive inverse of 8x squared minus 6 would be negative 8x squared plus 6. I made both of these terms the opposite. Or you can think of it as, in front of this parentheses is a negative 1. And negative 1, if I distribute it to 8x squared, would be negative 8x squared. Negative 1, if I distribute it to negative 6, would be positive 6. So either way you think about it, either as subtraction or distributing a negative 1, it makes what's behind the additive inverse. So are we done? No, we have 6 terms, 1, 2, 3, 4, 5, 6, and now our job is to collect them. All right, we talked about this. We want our answer always in descending order. So let's look for our biggest exponent, which is this square. So we have a negative 7x squared, and we want to put that together with a negative 8x squared. They're both negative numbers, so we would add, and we would get negative 15x squared. After an x squared in descending order would follow an x. So I have a negative 6x and a positive 28x. This number is negative, this number is positive, so we would subtract. 28 minus 6 is a positive 22x. Our last thing after coming in x would be our constants. That has no x. I got a positive 10 and a positive 6. They're both positive, so I would add, and I would get positive 16. We know we can't go any further because, again, look, we see addition. You can only add terms that are alike, and an x squared and an x will never be alike. They stand for different words. This may be x-ray machines, this may be xylophones, not the same word. So none of these terms are alike. We have it written in the correct descending order, so we know we're finished with our algebra expression. We have simplified. And that's it. Okay, now that we've talked about addition and subtraction, what's our next operation coming up? You got it. We're going to start multiplication. See you in the next video.